The reflecting telescopes use mirrors. We call them reflecting because they reflect the light instead of refracting the light. We're looking at a mirror from the edge, and light is coming from the left side. It hits the mirror and it comes to a focus point or focal point, same as in a lens, except in the case of the mirror, the focal point is in front of the objective mirror. In the case of the lens, it's behind the objective lens. So this is the image that forms in front of the mirror. To inspect this image, we also need an eyepiece. So here's an eyepiece to focus on the focal point. Here's our observer. He's looking at the image here at the focal point, except in this case there is no image because light never enters the lens or the mirror, because the light is going to hit the back of the head of our pirate. So in this case, this is a very impractical way of using a reflecting telescope. The only way they could figure this out was to tilt the mirror here to the side so the image was here in the corner, and that drastically reduced the sharpness of the image. Enter Sir Isaac Newton. He suggested to use a flat mirror in the front called a secondary mirror. So now we have two mirrors. This type of telescope is called a Newtonian telescope. In a Newtonian telescope, there is a primary mirror. That's our objective. It brings a light to a focus, but is intercepted and redirected to the side of the tube of the telescope. So here's a focal point of light. We use an eyepiece to focus this image here. So Newtonian telescope used two mirrors, one to gather the light and one to redirect the light. This is an example of a Newtonian telescope. This is our primary mirror in the back. The disadvantage is that when you carry this around, the mirror shifts a little bit, and the collimation between the primary mirror and that little tiny secondary mirror most of the time is lost, so we have to recollimate or reposition the mirrors to get a perfect image. In this case, the observer is looking through the eyepiece and is focusing at the focal point of the telescope. This is called a focuser. It moves the eyepiece in and out because every eye is different, so every observer has a little different focusing point. Once the Newtonian telescope gets to be big, like this telescope, it becomes very unruly. You're going to need a ladder like this to reach the eyepiece itself. Very, very inconvenient, unfortunately. So Newtonian telescopes have a limit. Most of them are used by amateur astronomers. The Kessie telescope is one design that has been favored by professional astronomers because the telescope is very compact and also has the focal point behind the primary mirror or the primary objective of the telescope. This makes it very convenient for installing big cameras and spectroscopes, so you can put a lot of weight behind here, whereas in a Newtonian it makes the telescope out of balance because you put the weight on one side of the tube of the telescope. So two advantages to the Kessie telescope. One is that the focal point is behind the primary mirror, not in the front of, and it's also a very compact telescope as well. The Space Telescope happens to be a Kessie telescope. This is the primary mirror of the Space Telescope, and this is the secondary mirror of the Space Telescope. This tube here is made so that it protects the secondary mirror from stray light. So light comes in through this hole. This is a cover for the Space Telescope. Light comes in and hits the primary mirror. It bounces back and hits the secondary mirror, and it bounces back again and goes through the hole in the center of the primary mirror and enters this area where you have the spectroscopes and the cameras and all the detectors of the Space Telescope. The Future Space Telescope also is a Cassegrain type telescope. In this case, it's coated in gold because it's an infrared type telescope. So light comes in, hits the big gigantic mirror, it bounces back and hits the second mirror here. This is a secondary. Bounces again, goes through the hole in the middle of the primary mirror. All the instrumentation is behind the primary mirror. It also has a gigantic sun shield that protects it from sunlight.